Greetings, children. Today we're going to be discussing section 6.12. It's on page 223 of your books, and we're talking about finding probability. Now, let's look at the definition that's on that page. It says mathematical probability is a number expressed as a ratio that shows how likely it is that something will occur. Now, a lot of times when you hear probability, you hear it expressed as a percent. If you look here, though, in your exercises, it's going to ask you to write it as a ratio. So a ratio is just a fraction, and we're going to express it in lowest terms. So if you had a probability of like 2 out of 50, 2 over 50 would reduce to 1 over 25. So you'd say you have a 1 out of 25 chance of it occurring. So probability is used in all kinds of things. Anytime you play a board game where you roll a die or a set of dice, you are talking about probability. So if you roll a die, then you have a 1 out of 6 chance that one of those things will occur. So if the die has the numbers 1 through 6 on the different sides and it's a regular 6-sided die, you'd have a 1 out of 6 chance of rolling each different number. So to roll a 2, you'd have a 1 out of 6 chance. To roll a 6, you have a 1 out of 6 chance. To roll an even number, you'd have a 3 out of 6 chance. So 3 out of 6 would mean 1 out of 2, because 1 out of every 2 of the numbers are even, because you have 2, 4, and 6, and then the odd ones would be 1, 3, and 5. So take a look at the second paragraph. It says probability is used by life insurance companies to determine how long a person of a certain age is likely to live. A doctor can use probabilities to determine how likely it is that a certain medicine will have an undesirable effect. Store managers use probability when determining how much stock to order. A weather forecaster gives a probability of precipitation for a certain day. So you can see here probability is used in a variety of different fields and all kinds of different things. So we're just talking about how likely it is that something will occur. Let's take a look at the next paragraph. It says, in 1795, the French mathematician Pierre-Simon Laplace defined probability as the number of favorable outcomes to the total number of possible outcomes. So that's our definition there. You can see there's a little bold thing. It says probability equals the number of favorable outcomes or results divided by the total number of possible outcomes or results. So let's go back to our die rolling example. So if we had a regular 6-sided die and we roll, so we shake it, roll it, we get a 2. There was a 1 out of 6 chance that we would get a 2. If we pick it up, shake it again, and give it a good roll, there's another 1 out of 6 chance that we'll get a 2. It doesn't actually change the probability of us getting a 2. It's always the same probability that we'll get a 2 when we pick it up and roll it. Now, there is something called compound probabilities, and then we talk about that later. But compound probabilities take the independent probability that we're talking about in this section, and it says, what happens if we want to roll all 2s? Or what happens if we want to roll 7 2s in a row? Well, that probability is different because you're asking a different question. But what we're talking about is just a single action, taking a die, rolling it up, and seeing what's the probability that we'll get a 2. Or what's the probability that we'll get a 5, or an even number, or an odd number, or a number greater than 1. So let's take a look at example 6.12a. It has a little spinner, so imagine that you had a spinner, and if it lands on a line, then you just respin. So it has to land on a number. So it asks a couple questions. It says, what's the probability that the pointer will stop on 5? So if you look at our definition. It says the number of favorable outcomes. Well, there's only one 5 on there. Out of the number of possible outcomes, there's 10. There's 1 through 10 as the numbers. So we would have 1 out of 10 probability, or 1 out of 10 chance to land on a 5 for that example. And then the next question is, what is the probability it will stop on a 2 or a 5? Well, there's 2 favorable outcomes this time because we have a 2 or a 5. So there's still only 10 possibilities. So 2 out of 5, or 2 out of 10, would reduce to 1 out of 5. So there's a 1 out of 5 chance that you'll get either a 2 or a 5. Okay, let's look at the next example. It says, a jar contains 3 white marbles, 5 blue marbles, 2 green marbles, and 1 yellow marble. What's the probability that a blind man will take a green marble out of the jar? So we would take a look and see how many favorable outcomes are there. So it wants to know green marble, there's 2 of them. And what's the total number of possible outcomes? Well, we'd have to add up all the marbles. So I have 3 plus 5 is 8, plus 2 is 10, plus 1 is 11. So there's 11 total marbles. There's 2 that are what we're trying to pick. So we have a 2 out of 11 chance to actually pick a green marble out of the bag. Okay, so you look for the number of favorable outcomes, the ones that give you the result that you want, and that's going to be over, in a fraction, over the total number of possible outcomes. So that's why if you rolled, let's say, 2 dice at the same time, there's a lot more ways than just 6 to roll, because you could have a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4. But we'll get to those type of probabilities in a later section. So the ones that you're going to be working with today are fairly straightforward. They're just an independent probability, and you're just trying to find the number of favorable outcomes over the number of possible outcomes, and then reduce that ratio or fraction to get our probability. Alright, as usual, if you have any questions, feel free to ask. You can call, text, or email. Thanks. Have a great day.